React experts now, so I can skip the part about React. Right? All right, so I've been doing React development for about 4 or 5 years now, and used varieties of different patterns in the past. Some of them are discovered by me, and some I discovered by reading blogs and internet posts and videos by other people. And this is just a compendium of all these different patterns that you will end up using inside your own React applications as you scale them over size. So if you think of the purpose of a UI developer or the purpose of a React developer, what you're really doing is you're taking a flat mockup that you receive as some kind of a design input, and then you're creating a flat graphic on the screen. The screen is flat, so you're taking the flat mockup and then creating a UI, which is again flat on the screen. But in between, you create this component hierarchy. There is a series of components that you have to create in order to present that particular UI. And this is the process in which you need to translate the mockup into the eventual UI that you see on the screen. And this process of translation, which involves creating this set of components, is not always straightforward. You end up creating too much responsibility into some of these components, and they become monolithic over time. And we will see some of the patterns over here today, which can help you kind of simplify these things and make it easier to scale your applications over time. So let's take a very simple example. This is a watch face, an Apple Watch face that you have to create, let's say. And your designer comes and gives you this fancy little watch face that you have to create. But when you look at this, it looks flat, and eventually also has to work with the thing spinning around. But in your mind, you're already imagining the set of components that you have to create to make this watch come to life on the screen. And you could actually blow it up, maybe. You have all these different little components that you have to use in order to pattern them together. And your job as a UI developer is to take these components, flatten them out, and then render them as a React UI. So that's the whole job of component-driven development, where you're trying to identify the visual boundaries between different parts of your UI and then create components out of them. And in doing so, you create a scalable component hierarchy, which can kind of do just the thing that it needs to do to render that part of the UI. So what are the core principles? So all of these patterns are actually built on certain core fundamental ideas. And many of them come from object-oriented programming, functional programming, and things like the solid principles. So how many of you have heard of the solid principles? You're all familiar with that, right? Solid? It was an acronym coined by Uncle Bob Martin, which basically stands for single responsibility, open close, list cost substitution, interface segregation, and dependency inversion. But all of those things are actually not that important. The most important that you need to remember is just the S inside the solid, which is single responsibility. And single responsibility is the one guiding principle for pretty much everything in software development. What we end up doing with a lot of our components in React is we bake too much things into it. A component is rendering things. It's also managing state. It's firing actions, making network calls, and all kinds of things, right? But that's not the purpose of a component. A component's job is to simply render the data. It's a visual representation of your data, but we're actually trying to do way too many things inside that component. And that's something we should stop doing and try to identify the boundaries between different components and the difference between state and a component. So single responsibility is going to be a guiding principle for pretty much every single pattern that we'll see today. We're talking about components, right? And already some of you attended Venkat's session, so you already know what a component is. But to kind of summarize, a React component consists of props, which are the inputs into the component. And think of it like a black box, right? You have a function call being made, and components can be just a function. These are the props, or the inputs that you receive inside a component. And then you produce some output, which is mostly virtual DOM. But besides the virtual DOM, a component also produces other kinds of output, which is events. Events are the way of communicating between the elements inside your tree. So someone somewhere deep below is not going to actually talk directly to the state manager and say, change this. Instead, it fires a series of events. And these events are the ones which eventually cause a change in the state, causing the whole thing to render again. But a component can also have state internally, and that's the private state. And through the power of props and state, you are creating a derivation, which is the UI, the virtual DOM that you see up on the screen. So if you heard of the equation where UI is a function of state, right? It's a very standard equation you must have heard if you're talking about Redux or UI development in general. So in case of React, it happens to be a UI, which is a virtual DOM, is a function of your props and state. By combining the props and the state, you can construct the virtual DOM for that particular component. And this keeps on going on as you create the complete component hierarchy. So, and when you talk about components, with component hierarchies, there are these islands of components or clusters of components which come together to build up a feature, right? So let's say you are creating a login form. The login form may have additional things around it also, like a sign-up form, forgot password, remember me, and then other kinds of things going on along with it. So this is all the login feature, let's say. but this login feature may be implemented through a hierarchy of components. And you are identifying a cluster of these components inside your component tree to represent that particular feature. So when you're talking about component development, component-oriented development, you're mostly focusing on extracting and understanding the various components needed to represent the visual state of the UI. The next important aspect is the data. Now, data in React is always supposed to flow top-down, one way, unidirectional. There cannot be any other way of doing this. So data always starts at the top, which is most likely some kind of a JSON blob you receive from your server, and then it trickles down into different parts of your UI and goes into different parts of your components. And every component may not need every part of the state, right? So you'll only need maybe a small section of it, and you pass it down as props. So somewhere at the top, you're accumulating all the state in your UI, and then as you keep going down into the hierarchy, the state becomes smaller and smaller. It becomes a smaller subset of what you actually need to render that particular component. So data always flows down. And the opposite is the events always flow up. So data down, events up. It's like a guiding and a philosophy in which UI should be built in general. So with these concepts in mind, we can now talk about the most fundamental relationship in React components, which is producer-consumer. In fact, if you forget about everything else in this talk, just remember this. The most important relationship in the React component tree is that of producer and the consumer. Someone is providing something, and the other is consuming it. And this goes on as you create your complex hierarchies of your components. So what is this producer-consumer thing? It's a standard computer science concept, but it manifests differently when you talk about React components. So there are several kinds of producers. The most standard one is the container presentation one, right? You must have heard of that if you're talking about Redux. There is this classic way of separating components between container and presentation. But that's just one of the ways in which you can create a producer component. A producer is the one which creates the context and environment inside which the presentation or the consumer can live. So you can have your container components, you can have layout components, which provide a placeholder for all the other components. You could have data, which is basically what you get in the container components, which connects to the store and supplies that as props to your presentation components. And also service components. Service components are the ones which kind of wrap things like your authentication, or talking to the service, or maybe talking to analytics service, making some network calls, and so on. These are all different contextual elements that you wrap inside your producer and then provide it as a prop to your consumer. And by creating these producer-consumer hierarchies, you can actually create an entire component tree. Now, on the consumer side, of course, you have controls, which are just the input controls. They could also be the presentation aspects of taking in the props and preparing a visual representation of that particular state. You could have sub-layouts or partial data. These are all the consumption aspect of your data. Someone somewhere is actually getting things, and someone is actually consuming things. So production and the consumption part are the two important aspects. They're the dual of your React components. And this probably is the most important relationship inside your React component tree. So with that, we can actually start with the patterns. So we know that the core philosophy is around single responsibility and establishing this producer-consumer relationship. So let's start with the first one. And as I talk about these patterns, I'm going to actually flip between the code and the slides, and we can actually see how these things work in the code as well. So higher order components. Almost everyone over here must have heard of higher order components, right? Anyone who hasn't heard? Don't feel shy. So higher order components are basically just a way of creating components that wrap other components. And the reason why you need to do higher order components is because one component should not take on the responsibility of someone outside. Right? We talked about single responsibility. When you see that the inner component is kind of doing too much, it's probably time you want to break it apart. And maybe create as a composed component where one component is enclosing the other, or maybe have two separate components which are kind of living side by side. But what would be the case? A higher order component normally takes in a component itself as an input that acts as a consumer of the producer. Right? So the higher order component, the wrapper one, is actually the producer, and the one inside of it is the consumer. And you'll see examples of that in frameworks like Redux and MobX, where in, let's say, Redux, for example, where you have the connect that you do inside your React components, that's actually a higher order component. That connect is actually connecting to the store and getting whatever you need to present inside the presentation component. So it's acting as the producer of data. And the consumer, which is the presentation component, is simply taking it as props, which is what you do in your map state to props, map dispatch to props. It takes those things as props and then uses it to render out that particular part of your UI. So that's higher order components. And there's a library called Recompose, which is again created by someone at Facebook, which kind of relies on higher order components to create all kinds of complex things where you don't have to go through the process of even creating a class or a function for a React component. you can simply use functional composition to create these components, where because ultimately the higher order component is a function composition. It's a function wrapping a function and giving back a component. Now, a different way of looking at higher order components is, or the producer-consumer relationship is in the form of function as child. Now, it's a little known fact that the React component, the children of a React component, can literally be anything. It doesn't have to be the component itself. It can be a function, an object, a string, anything. So if you use a function as the children of your React component, you suddenly have the power of actually passing in a function into a React component. And that's what function as a child component is really all about. You basically pass a function, which is what I'm doing in the args over here. I have created the JSX interpolation block, and I'm simply passing a function into a higher order component or a higher level component. Now you'll see this pattern being used in some libraries like the React Motion, which was the one to actually introduce it first, where you want to pass in the presentation component as a function into a higher order component, which is the wrapper over here. So passing the functions as child components, you get more flexibility in terms of where the wrapper doesn't have to actually create a new component on the fly, but simply uses the child function to create the component itself. It may not be that obvious when you see it in slide, so let's jump into code right now. So what you're going to do over here is see how we can use clocks, the watch face example, to create more and more complex components and use all these patterns to actually build these clock components. So we'll start with a simple time. So this is just a time. It's not even ticking right now. And the way you want to make this time tick is to kind of separate the fact that there is data, which is the time, and this presentation, which is the text that you're seeing over here. So you want to separate these two things. And there are several ways in which you can separate it. The producer is the one who's going to produce the time, which is a continuously changing value. And then you have the presentation, which is the UI, that's going to render that continuously changing value. So let's see how we can do this. So let's start with the higher order component. So here, what I'm really doing is, actually start with this one. So in simple time, just to kind of set the context, what we're really doing is creating a simple div and then formatting the current time. But it is always the current time. It is not actually changing at all, right? So this moment is from the moment library. This is something that needs to be changing, and the React component needs to be rendering it constantly. So how do we separate these two things? So we have data which is coming in the form of a prop, and right now I'm not taking any props inside this component. I somehow need to separate these two things, right? So the first thing I can do is kind of call out the container aspects as a separate component. So I'll create a separate component which is called the time teller. So I've created a component over here, and you can imagine the kind of functionality we'll have here. So we have an internal state, and what I'm doing in the mount is kind of creating a timer which will tick every second and then produce a new value of the state. And I'll pass this state down into any component that needs it. So that component could be a child component, or it could be a function as child component. It doesn't really matter. But what I'm really doing over here is passing that state into the child and calling that as a function. So this is the function as a child approach, where you are simply taking the data that you have, which is in your current state, and you're passing it down as a function. And the place where you use it is something like this. Can you guys see it at the back? The time teller over here is simply taking in a function. Let me just kind of make this a little more clear. So the time teller is taking in a function which is containing the time, and then it expects a component. And it uses the output of this function to render the higher order component itself. So here I'm using the function's output and rendering that as my virtual DOM. Making sense? Everyone clear? So that's how I'm actually separating the responsibilities. So one component is actually producing data, and the other component is simply taking the responsibility of showing what the data looks like. And just by having these two things, we can now separate these two into separate components, and we can start using them inside other places. So let's look at the ticking time as a higher order component, or rather render props. So this is an example again where you don't really care about how the data should be presented, right? The time teller doesn't know anything about that. Let me just close this guy. So here the time teller doesn't know how the data will actually be presented, but it's actually taking in a function and simply rendering it out as a formatted value. So this is the way in which you're kind of separating two different things: the data, which is the time, and the presentation, which is how it should show up on the screen. And there are two ways of doing this. You can actually do this as a function as child, which is what I've done over here, or you can also wrap it in a higher order component, something like this. But this requires you to actually create the component and keep it separately. So here what I'm doing is I'm creating the ticking time as a higher order component, and with time is just a convention that is used for a lot of higher order components, where you take the context that you want to capture and then pass that context down into any component that needs it. So here I'm creating that with time as a higher order component and taking in a component which will eventually render it. And you can see the definition of with time is simply using the time teller component. It's simply taking a component as input, and then it takes whatever props it receives and then passes it down into the component, also passing in the context that it's actually trying to capture. Right? So in this case, we're capturing the time, so I'm passing in the time into this component, along with any other props that you have received when you're defining that with time component itself. So this is how you're kind of separating these two components over here. So one is just a composition where you are simply creating a function that returns a component and accepts a component as its input. So you have wrapped that component in a sense. So, the render method is part of the time teller. So time teller is actually setting up the timer, which is ticking every second, and every second you're changing the state. So every time the tick happens, we are setting the state to some new value. So every second I'm actually changing the time value. And then since you call set state, the re-rendering of the higher order component, which is the time teller, will happen. And whatever component was passed as a prop or a child into the time teller will be rendered out over here. So what I'm really doing in the time teller is kind of setting up the timer and all of the machinery that is needed to pass data down into the hierarchy. Making sense? I'll put up the code also for this so that it's more clear. It may probably because it's too far away or there's a lot of JavaScript stuff happening over here. But essentially think of it as the producer consumer over here. Right? This time teller is producing time, and the consumers, which have been attached in the form of a function or in the form of a higher order component like this, are simply consuming the time and rendering it out. All right. So those are the two ways in which you can actually kind of separate the producer consumer, but there's a lot more that you can do over here. Now domain components. Now whenever you're trying to model things inside your UI, you're ultimately dealing with a specific domain. It could be finance, retail, luxury markets, could be anything. Sorry? Right. Right, so I kind of mixed and matched these two things now. So what I've done is I created a higher order component which is with time and reusing time teller inside. And time teller itself takes a component through its function as child approach. Right, so we're kind of mixing things over here. You can do it in any way you want. You can actually not even have a time teller and just have this passed in as a child directly. Because we have the time teller already created, we're just reusing it in the higher order component. This is just to abstract the time aspect and pass it down into the child components. So you could be doing it in two different ways. I just give you an example over here where you're kind of using one in the other. So you created a higher order component just because you want to use it as a function. But if you want to use it as a regular component tree, you can just use the time teller by passing it a function as a child. So you have two different ways in which the same component is being reused in two different ways. Yep. All right, so let's go back to our slides. So domain components. Now, ultimately what we're doing in UI is mapping some data in a domain to the visual representation. Right? So domain is the most important aspect over here, and we should not forget about that at all, because the vocabulary that comes inside your UI is actually coming from the domain or world itself. So there is something called as domain-driven design, which you may have heard of, which is basically about modeling the data aspects of the UI in such a way that you give some visual vocabulary to it. Right? So if you're modeling a contact, then the contact itself is an entity inside your domain somewhere, and you're modeling it through a contact component by rendering the different fields of your contact. So whatever component names you end up choosing, they actually come from the domain, and you can use this idea to create specialized components which match the domain as closely as possible. So let's see this a little more clearly. So before I go there, I want to show you the clock itself. So we have more complex clocks. So let's take this one. So this is a very complex clock. Right? There's a lot of things going on over here. And similarly, there are other clocks as well. Let's look at this one maybe. This is even more complex. There's a lot of stuff going on over here. There's animations, there is ticking time, there is the thing rotating around it, so on and so forth. But all of these things are actually relying on one data point, which is time. And everything else is presentation. But how do you create the presentation? Right? This presentation itself is quite complex. There's a lot of layered components that we saw earlier. So we'll use some of these patterns to kind of capture this complexity and manage it in a nicer way. Let's go back to the code now. So what I want to show you next is the domain concept, the domain component concept. So let's take the analog phase over here. So if you read this, the render part, the component that we're using over here, you have something called as a watch shell. The watch shell kind of sets up the top level container inside which you're rendering everything else. So here, this rim that you see along with the buttons and the strap, that's the watch shell. In fact, I have just the component for that, which is just the watch shell, which looks like this. And this has a bunch of properties, which can use to color the strap and buttons and the rim and all that. But that's essentially the top level component. And what I've really done over here is captured the aspect of the domain, which is the watch shell. Right? I could have simply taken this component and taken all of this JSX and dumped it at the top level itself. But that would make it really complex. Right? What you're really trying to do is this complexity is now managed by creating a specialized component called watch shell, which hides all the details of what this watch shell actually looks like. It has straps and buttons and rims and all those things, but I don't have to worry about it. I can just assume that will be provided to me, and I'll get a placeholder inside which I can fit in other things. So here what I've done is I've taken the watch shell, which is a domain component, and there are other domain components as well over here, like radial tick marks. Then you have radial tick labels. You have progress ring, hour hand, minute hand, and if you had a second hand, you would have shown that as well. So essentially what you're doing over here is you're mapping the vocabulary of the domain, which is mostly talking in terms of, if you're talking about describe a clock, this is how you would describe it. Okay, I have some kind of a shell around it, I have buttons, I have some hour hand, minute hand, and something, the labels around it, right? So you're simply taking the vocabulary of your domain and mapping it into these components. And you're doing it by giving it very specific names, which matches the domain vocabulary, rather than trying to take the DOM of the minute hand and dumping it directly inside into your top level component, which will just make it way too complex, right? So that's about domain components. And domain component doesn't just have to be about the names. It can also be some services or additional context that you're trying to capture inside your domain. And all of those can be wrapped, just like we did with the time teller, inside a component and then exposed down into the consumer components. So this is more about relying on the vocabulary of your domain and trying to create separate specialized components which will match the domain as closely as possible. And in this case, all of these hands, actually, the hour hand, minute hand, and we also have a second hand, they actually derive from the hand component. So we have one component called the hand, which is over here. So this is the hand component, and it has a bunch of properties on it. And the DOM is something like this. I could have taken all of these DOM and dumped it directly inside the hour hand and minute hand. And there is some calculation also going on over here just to get the right rotation of the hand. And all that logic is captured inside the hand component. Right? So don't worry about all the details, but there's a lot of stuff going on inside to kind of show you the DOM of the hand itself. But what we've done instead is create specialized components, minute hand and hour hand, which are wrapping the hand component. This should really be hand, but not React component. And here is where you're kind of simplifying the DOM and adding more vocabulary into your UI. All right, let's go back to the slides. So this is all about the ubiquitous language of a domain and kind of moving it into the UI as well in terms of creating those components. Now compound components. This is a pattern that you'll notice when you'll start seeing components which are accumulating a lot of properties. And what is really happening over here is that your visual tree is very complex, right? And in order to cater to different aspects of a visual tree, you are exposing properties at a very high level. And what ends up happening is that you expose a lot of properties at a very high level and makes the component itself very monolithic. So here is an example where the gray component actually is just one component, but internally renders out a very complex component tree. It's better to actually break it down into its individual components and then makes it easier to customize them also. So let's see an example. So this is a compound face, and what it's really having is a ton of properties. In fact, if you look at the default props, we have a lot of properties over here: strap, rim color, and then it's taking some visual representation for the minute mark as a render prop. So you can use properties which can also create components, and you can apply these components wherever you need. So you have properties for all of these different components, different parts of your watch. So you have hour mark, minute label. So you have a ton of properties like this. And when you start using this component, which is somewhere over here, this is what a component looks like: a custom analog face. And look at the number of properties you're providing. It's quite complex, actually. And all this is because you want to expose some kind of customization at a very high level. Now, instead of doing it this way, it's better to actually break it down into smaller components and expose customization at the smaller component itself. So rather than exposing the properties, you can actually create components, which we did earlier with the minute hand, hour hand, and so on, and let the user decide how to compose them together. So a different way of doing this would have been to actually take these components and use them directly. Right? So instead of passing them as prop, where you are creating this component, you can use these components directly: the hour hand, the progress ring, and so on, and let the user customize whatever they want it. In fact, they can mix and match things, right? Because if you do it at the compound component level, you will have to bake in the visual tree in a certain order, right? The components have to come in a certain order, a certain parent-child relationship, and so on. But that gives you, although you can give the styling aspects to it, you can't really customize the tree itself. Right? If you want to change a few things around, you can't do it, because you kind of created a very fixed tree and exposed properties to customize different aspects of the tree, which are only the styling aspects. But if you want to change the tree itself, it's not so easy. So a compound component actually breaks the tree and says, you know what, we're not going to expose properties for every little thing that you want to customize. Instead, I'll give you the various sub-elements of the tree itself, and you go ahead and customize the way you want. So this is what we've done over here. So we have separate components for different aspects of the tree. So let's say you want to add more components to it. So this is the analog face, right? So you can add more things to it. And let's say hour hand, minute hand. You can also add a second hand over here. Let's see, that takes it. I don't think it was there earlier. But essentially, that's what you're trying to do. You are trying to pass, oh, this is the time I need to pass. Okay. So you can create these components yourself and compose the tree in whatever way you want. And that's the power of these compound components, where you're breaking the tree and making it easier to compose components. All right. And one thing that is kind of not always mentioned in these compound components is that there is some shared data across all of the component tree. And you do that by managing it through React context. And we'll see React context itself is a component pattern that is exposed in React 16.3, where they created a new API around it. Control components. Now this is probably the leaf components of your component tree. And what control components really do is allow you to accept some input and render out that input. Classic examples are input components, date pickers, month pickers, and selection controls. These are all the control components of your React tree. And what they take in as input is a simple value, and then a bunch of callbacks which tell you when certain things have happened at the control. So if the value of the input changes, you fire the on change. Or if some other events need to be fired up, you actually fire these as callbacks to the higher level component. And this way you do data down, which is the value that always comes down, and events always going up. So let's see an example of this as well. Control components. So let's focus on just this part. So you have a form, and in UI this looks something like this. So you have a simple control, and all you can do is simply change the time over here, right? And then it tells you what time you have picked. It's a fairly straightforward component. Now what you've really done is wrap this particular aspect of the time picking aspect, or time selection, into its own component. And by doing this, what you're really doing is you're removing the complexity at the higher level component. That whatever complexity was there of managing the time input is now baked into a component of its own, which takes in a label, a value, and an on change. So we created this as a controlled input component. And it's called controlled because you are controlling the value, and they are also deciding what should be shown in the component itself. The component itself doesn't use data or state of its own to render itself out. It always receives its state from the outside through the value property. So you have a controlled component over here. And you will see this mentioned in the React documentation as well. Anything that is controlled means it receives its input values always from the outside. So here is where we're actually kind of taking the complexity of the time input, creating an input tag, we're specifying a specific type to it. So all the details of how this component should be used is wrapped inside this time input component. What styling you want to apply and so on. The only thing that needs to be exposed from this component is the value prop and the on change prop. And by doing this, you kind of simplified the contract at the higher level. I don't need to know, how it's being styled or how it will be actually rendering it out at runtime. I can only worry about the fact that I need a time input at this point in my UI. So that's about control components. And here again, you will see the producer-consumer relationship happening in some form, right? So the time input is the consumer. It's the consumer of your value. And any events that happen inside the consumer component are notified to the outside world. They don't take any action of their own. They don't have any intelligence of their own. All they're really doing is forwarding things, right? Any events that happen inside the control component is simply forwarded to the outside world, to the higher up components, and just consuming the values that is received from the outside as props. So here again, you can see the producer-consumer relationship showing up. All right, let's jump on to the next one. Now this is a classic one. You must have already read about this inside, whenever you're dealing with Redux. And container presentation is how you kind of create the separation in components when you talk about connecting to the store and consuming the store as a presentation component, right? So the store is a classic example, which is the connect method in your Redux. But you can also have other kinds of producers, styles, and styled components is what you must have heard. If you heard about things like glamorous, or style components, or JSS, or CSS in components. These are all essentially ways of capturing the styling aspect, the class names and the style properties, and creating a component out of it, so that people who are using it don't have to know about the exact details of the styles or the themes that are being used. They can just wrap it inside the styled component and get the output that they need. That's again the container presentation, where the details of the style sits in the container, and the presentation simply renders out whatever it needs to. So you'll see this example again. We've seen it several times already. And anytime you have a container presentation, and the most simplest one is the watch shell, right? So the watch shell is having this complex tree over here, which is acting as a container component right now. So it creates the SVG. It has all these linear gradients and groups and recs and all of those things. And somewhere below, it creates a placeholder through the time teller, right? So the time teller now simply requires you to create a component that will render out inside that watch shell. And it could be anything you want. It could be the ticking phase. It could be a simple time. Or it could also be a digital phase. In fact, we have examples of that as well. Let me just show you that. So here is a container presentation, a more complex looking watch, right? The watch shell and everything is the same. There's nothing changing over there. It's just acting as a container. And the stuff inside can be anything you want. In fact, using this approach, you can create a gallery of watches and use all the different components that we already have as domain components to compose them together. So you can have your text, your ticking dots, your progress rings. All of these things can be put together the way you want and without having to worry about going through a very fixed hierarchy. So this is using a combination of techniques over here, where you use a watch shell as the container component, and then the stuff inside is the presentation aspect. So that's container presentation, and it's really about separating the concerns between the container and the presentation. Again, seeing the producer-consumer relationship over here, right? It takes on single responsibility as the primary way in which you want to create your components. It should not do more than one thing, and whatever it does, it should do it really well so that you don't have to worry about the way it does it. The how aspect is kind of hidden away from you, and you only want to worry about that name of the component when you're seeing it in your component tree. The next is error boundary, and this again is an extension of the higher order components and the components which take in other components as inputs. So what error boundaries do in React world is that anytime a component throws an exception in any of its lifecycle hooks, it will catch that and then show a error to the user. So let's see this right now. So all of these components, they're all now extensions of the same principle. Higher order components, function as child components, and you're all just seeing different ways in which you can model the component tree by using these ideas. So here you have a failing phase, and this just fails up in 3 seconds. So what has happened over here is that after the component has failed, of course it throws an error in the development board, but in reality it has actually shown a different view of the error, which simply says game over. So if I just refresh this, you will see the component now working, but at some point something fails in the lifecycle hook, right, which is happening in the component did mount right now. And because something failed in the lifecycle hook, and this could be something like you're trying to dereference an object which doesn't exist, like undefined is not a function kind of a thing, or it could be you're trying to make a network call, but the service is not ready yet, or something of that sort. It could be exceptions of any kind that can be caught inside your lifecycle hooks, and when those exceptions happen, your component's visual state can change. And that's what the error boundary really does. So in code, this looks pretty close to what you would imagine what an error boundary component should look like. So let's look at that. Error boundary. So what I've done is I've created a component called blow up in X seconds, and it simply sets up a timer and then throws an exception when the timer completes. So we are capturing the current state, and then when the timer completes, which is over here, I'm setting a state to the error. Now it's important to realize that error boundaries should be catching the exception synchronously inside the hook. So here, if you were actually throwing the error inside the set timer, it would not actually cause an error, because this is not synchronously happening inside the hook itself. Just because you wrote the code in the hook doesn't mean the error also gets caught in the hook. Right? It's a very important aspect of error boundaries, where this error needs to happen in the hook, but not through the async function that you're calling through the hook. So here what I'm doing is I'm calling set timeout inside component did mount, which is a lifecycle hook, and inside that I'm going to throw an error. But that won't actually work, because error boundaries require you to throw the exception in the hook itself. So that's the reason why what I'm doing over here is inside the render, I'm throwing an exception. And because I'm throwing it inside the render, the error boundary can actually work. So this could be most likely the case where you're trying to dereference something, or making a call which could fail, or trying to call a function which doesn't exist, and so on and so forth. But the idea here is that anytime these exceptions happen anywhere inside your component tree, the error boundary will actually catch it and then show a different UI. So here is the case where we're actually using this component, so failing phase. Here is where we use the error boundary component. So I created a watch error handler, which is just a error boundary component. And then I have a component that actually fails in 3 seconds. And since these components are nested, this error boundary, which is a watch error handler, catches the exception that has been thrown in the lifecycle hook and shows a different UI. And the way it catches it is through a special hook called component did catch. This is a hook exposed by the React component itself. This is not something I'm creating. This is part of the React error boundary contract. So if you actually override this particular hook, then any exception that gets thrown in the component tree in the lifecycle hooks will be caught over here, and then you can take action on this. So here what I'm doing is I'm simply setting a state with the failed equal to true, and when that failed gets set, I'm showing a different kind of component with game over message. So that's all I'm really doing over here. So that's the error boundary component. Any questions so far, by the way? Yeah, so component did mount is where I'm actually setting up the timer. And when the timeout expires rather, I'm setting a state. I'm not actually throwing the error itself. Because if I throw the error here, it won't actually get caught. Because this is in an async call, right? At this point, the context is lost. You're no longer inside the hook. You just happen to be having the code getting called inside the hook, but you're not in the hook anymore. So if you throw an exception over here, inside the set timeout callback, it won't actually cause an error. So if I remove this, no, that's because I'm calling set state and passing in the error to it. And inside the render, I'm actually throwing the error. This is just a simulated example. But you can imagine that this could be caused through some JavaScript error or some other exception being thrown somewhere else. So if you throw an exception inside your lifecycle hook, only then the error bound will actually catch the exception. So it's very important to realize that this has to be inside the hook. It cannot be an async function that you're calling in the hook. And that's the reason why I kind of created this contrived example. And you can catch the error and use it to kind of take action on it, maybe if you want to. Maybe recover from the error, or just collapse the entire tree, or whatever you want to do. So that's the error boundary component. So think of error boundary components as the try-catch component inside your tree. If you have a set of components which kind of are expected to fail, and you want to probably show a different visual state for the failing aspect, you can wrap them inside an error boundary component and then use that to kind of show the fail state. Again, this is a higher order component, right? It is an HOC. So it's just one way of modeling the errors, where the error becomes the value that you want to push down into the lower components. So React context. This is again an example of, sorry, yeah. Yes. Yeah, so the error boundary will have a hook called the component did catch. And inside that catch, you will see the error that was thrown in the subtree. So if any component inside the subtree throws an exception in the lifecycle hook, it will actually call the component did catch of a higher level error boundary component. That's because you're trying to capture data, which is an exception that needs to be propagated up. This actually is a good point. You want to show data which you want to push down, but the data actually comes from below. It is actually kind of violating the data down events of principle. Yes, that's a good observation actually. So since the data itself, the error itself is our data, it has to come from below. And by only wrapping it, we're going to get the data. So this is kind of an exception to the rule where data always has to flow down. A good point. All right, so next is the React context. This again is a higher order component, but it kind of breaks apart the context aspects of React. Now, if you had used React context earlier, it required a lot of ceremony to actually set it up. You have to create your React context types, and then you have a child context. You have to pass the child context in your top level component, and then everywhere you want this React context, you have to kind of override the get child context hook, and then receive that context. And you can use the React context itself, which is an extra prop that is passed in inside your lifecycle hooks as well. So this was a very more complicated way in which the context was passed down into the tree. And React context, the idea is over here is that anytime you have something sitting way up in your component tree and you want it somewhere way below, it's very hard to string it through all the props, right? You don't want to do that because that kind of creates more complexity. So instead you have a separate data channel, which is called the React context, which is used to kind of pass data from any component to anywhere down below. And this kind of mitigates the fact that you have to create a separate prop and so on and so forth. So that was how React context was supposed to be used, but then it became more complex to use it because of this additional lifecycle hooks that you have to create just to use the React context. So what the Facebook team have done now is create a separate API for it called the provider-consumer pair. And here again you can see the example of the producer-consumer, right? They chose to call it provider-consumer, but in reality it's just producer-consumer. The producer being the context, and the consumer being anyone who wants to use that context. So let's see an example of this. Context, yeah. So what I've done over here is previously the time teller was passing in the time as a function as child component, right? So I've created some slight variation on this where I'm going to create a separate context called time context. And I'm going to call this API react.createContext. It's a special API exposed in React 16.3 and above, where you can pass in the context as the initial value. And you can also change this context. So anytime the context changes, anyone who is listening to the context will also be updated. So when you have this time context actually creates two components internally. So when you call create context, it actually calls time context creates two components called time context.provider, which is over here. And there's a time context.consumer. You're kind of separating these two things, right? So you can actually choose to use consumers wherever you want, and you can always have one provider. You can also have nested providers. You can actually create multiple providers and then nest them together. And then wherever you want to use a specific context, you can actually wrap it inside a consumer component, which is the context.consumer, and then use whatever you want to use as a function as child component. So what this consumer component does is it accepts a function as input. And we saw this earlier also, right, where you have this function as child approach. So time context.consumer actually takes in a function as input, right? It gives you the context itself as a prop, which you can then use to render out the way you want it. So this is a different twist in which you can actually render a time. So what I've really done is created the provider. So I have a time teller, and the time is now passed via context through this time context.provider. And we're passing in the value, which is a fixed property that the time itself is passed in as the value to the provider. And then wherever you have a consumer, it will connect to this provider and get the value from it as a property. Are you following over here? So we are kind of creating two separate components, one sitting somewhere else, which is acting as a provider of your data, and one which is a consumer, which is simply going to take in whatever data is being provided by the context. And so here you can see that the time presenter is simply a consumer of the context. It takes in the time and then renders out itself. So in terms of the UI, there is no change. So if you go back to the context example over here, there's no change as such. It's still working the way it's supposed to work, but the component tree is very different. It's now relying on React context to taking the time and then render it out inside the presentation component. So that's React context. Again, this is an example of your producer and consumer. So you have the top level provider, and you can wrap as many providers and consumers as you want over here. And finally, there is the component inside which you'll actually receive all of these as props, and you can use it to render out. So those are all the different examples of patterns. And you will see some of these patterns actually recur more frequently, like the function as child, higher order components. They happen so frequently that you have to give special names to them sometimes just to use them more clearly, right? So you have the function as child and the error boundaries, which is an example of the higher order component. The higher order component, so the error boundary is just a higher order component, but by giving it a special name, the meaning of error boundaries has changed completely. Similarly, you have domain components, where you're wrapping some context or some aspect of your visual presentation and then creating a placeholder component inside which you can fit in other things, right? So by creating these kind of components, you make the component tree a little more simpler to use, and then separate the responsibilities, make them single responsibility focused, and that is how you create component trees which are more scalable. And you can actually mix and match things more easily. And if things change over time, you can also replace these components more easily without having to worry about eliminating some functionality. So those are all the patterns. The most important relationship, of course, is the producer-consumer. You just apply the relationship and you'll automatically be able to arrive at the components that you need to render that part of your component tree. But there are a few more that I actually missed out. In fact, this list can actually go on a little more. There are other kinds of components like fragments. And fragments are special React components where you don't have to create a placeholder tag anymore. And I mentioned this in my previous talk as well, where a fragment is used previously to kind of wrap things together. So if you're rendering multiple things inside your virtual DOM, you always had to wrap it in a div tag previously. You don't have to do that anymore. You can actually keep it the way it is and wrap it in a fragment which doesn't render anything on the DOM. And it's just a placeholder empty tag which just keeps things together and allows the virtual DOM to work properly. There are other things like portals where you are rendering DOM always in one DOM element, right? You always do React DOM.render element somewhere at the top. But with portals, you can actually render multiple parts of your React in different parts of your DOM. And this is very commonly used in modals, where the modal has to sit on top of the other UI that you have on the screen. But this way, you can actually have the same React context and all the same state passed down into both these elements without having to worry about them being in two separate DOM elements. And then there are loadables, which are basically a way of loading components on the fly. So you can create something called as a React loadable component using the library called React loadable. You can make a separate network call on the fly, fetch the code for that component, and then render it inline. And you can see an example in React loadables. I'll encourage you guys to take a look at that. But this gives you a different way of rendering async components, where you don't want to pull in all the code at once, but only pull in the code that you need for your tree at any time. And only when you're navigating certain parts of your UI, you can actually pull in the code, get the components, and render it in place. So these are a few additional components that you can actually try out. And they're all examples of higher order components, function as child components, controlled inputs, and so on. So that's all. Those are all the patterns. This was just a quick survey of all the different ways in which you can create your component tree. Obviously, this is not going to make you well versed with all these patterns. I suggest you to take a look and also try it out yourself. But once you've done it, it'll become much more easier to manage your component trees. So that's it. Those are all the patterns.
Thank you, Pavan, for that wonderful talk. Guys, we'll now break for lunch. The next session in the hall starts at 3:10. Please join us for the town hall post-lunch in the main hall at 2 p.m.